You might think you know all there is about the solar system, but do you really? In this video, we'll uncover some often overlooked details. Let's start with Mercury, the planet closest to the Sun. Since Mercury is only a little more than one-third the distance from the Sun compared to Earth, the Sun appears nearly 3 times larger from Mercury than it does from our planet. Mercury is the smallest planet in our solar system, slightly larger than Earth's moon, and, unlike Earth, it has no moons of its own. Like Venus, Earth, and Mars, Mercury is a rocky planet with a solid surface covered in craters. Instead of a true atmosphere, it has a thin exosphere composed of atoms blasted off the surface by solar wind and meteoroid impacts. Mercury spins slowly compared to Earth, taking 59 Earth days to complete a single rotation. But because it's so close to the Sun, its year is short, just 88 Earth days. And with its slow spin and short year, the Sun only rises once every 176 Earth days. That's 2 Mercury years. Fascinating, right? Even more amazing, thanks to the 3-to-2 resonance between Mercury's rotation and its orbit, combined with its elliptical path, the Sun actually moves in retrograde in some areas, a phenomenon unique in our solar system. You might not know this, but Mercury played a role in confirming Einstein's general theory of relativity. For a long time, scientists were puzzled by the precession of Mercury's orbit. Mercury's perihelion precession refers to the gradual shift of its closest point to the Sun in the direction of its orbital motion. Astronomers observed that the actual rate of Mercury's perihelion precession is about 43 arcseconds per century higher than what Newton's law of universal gravitation predicted. Einstein's theory of general relativity provides a more accurate explanation for this discrepancy. According to relativity, Mercury's orbit is influenced by the curvature of space-time caused by the Sun's massive gravitational field, resulting in an orbit that is not a perfect ellipse, but a constantly rotating one. The precession rate calculated using this theory exactly matches the observed value. In fact, other planets also experience orbital precession. For example, Earth's orbit undergoes precession with a perihelion precession period of about 21,000 years. Our closest neighbor is Venus. It's a very active planet with mountains and volcanoes. Like Mercury, Venus has no moons. Its diameter is about 95% of Earth's, at around 12,104 kilometers, with slightly less mass and gravity. Unlike Earth, Venus is the only planet in the solar system that rotates clockwise, meaning the Sun rises in the west and sets in the east. It also rotates very slowly. One day on Venus lasts 243 Earth days, but its year, the time it takes to orbit the Sun, is only about 225 Earth days. So, a day on Venus is actually longer than a year. Because the day and year lengths are so similar, the Sun rises on Venus every 117 Earth days. This means the Sun rises twice during each Venusian year, even though it's still technically the same day on Venus. Ever wondered why Venus sometimes shows up in the early morning and other times in the evening? It all depends on its position relative to the Sun and Earth. When Venus is to the right of the Sun from Earth's perspective, we can spot it in the early morning before sunrise. Since Venus orbits faster than Earth, it gradually moves closer to the Sun and eventually disappears in its bright glare. These moments are called inferior and superior conjunctions. But don't worry, Venus reappears as it moves to the left of the Sun, now rising at sunset and lighting up the night sky. Interestingly, Venus in the star Sirius can sometimes seem to appear in the same spot in the sky, which can be confusing. For example, you might notice bright Venus at dusk and then see equally bright Sirius in the same place the next morning. However, Venus will never be close to Sirius because Venus orbits the Sun almost perfectly along the ecliptic plane, while Sirius is far from it. This happens due to Earth's axial tilt. So while you might see Venus in a certain direction at dusk and Sirius in that same direction at dawn, they're never actually near each other. Though Venus isn't the closest planet to the Sun, it's the hottest. In fact, temperatures on Venus are so extreme that metals like lead would melt into liquid puddles. This intense heat is caused by its thick atmosphere, made mostly of carbon dioxide and nitrogen, which is 92 times denser than Earth's. This creates a powerful greenhouse effect that raises the surface temperature to 467 degrees Celsius. Thanks to Venus's proximity to Earth and its highly reflective atmosphere, it's the brightest object in the night sky after the Moon. For a long time, humans have explored the feasibility of migrating to Mars, which shares some similarities with Earth. For example, Mars has liquid water beneath its surface, and its day lasts about 24.6 hours, only slightly longer than an Earth day. Mars has an axial tilt of 25.2 degrees, similar to Earth's 23.5 degrees, allowing it to experience 4 seasons. However, the average temperature on Mars hovers around minus 60 degrees Celsius, and its thin atmosphere is primarily composed of carbon dioxide, making it unsuitable for human breathing. Additionally, Mars's gravity is about 38% that of Earth, posing health risks for humans living in a low-gravity environment for extended periods. Clearly, until effective solutions to these challenges are found, the idea of migrating to Mars remains conceptual. In pursuit of the dream of human travel to Mars, SpaceX has made significant progress. The company is developing the Starship spacecraft for deep space missions, including those to Mars. Starship is designed to be fully reusable and capable of carrying large numbers of passengers and cargo. Given that the average distance from Earth to Mars is about 225 million kilometers, with the closest approach being about 54.6 million kilometers, the journey typically takes approximately 6 to 9 months. This makes on-orbit refueling a critical component of SpaceX's plan. SpaceX's orbital refueling strategy involves launching starships configured as tankers separately into Earth orbit to store and transfer fuel. Once in orbit, these tanker starships will dock with the operational starship to transfer their propellant. After refueling, the operational starship will be equipped with sufficient fuel to commence its journey to Mars. Whether the spacecraft will require additional refueling in orbit for its return depends on mission specifics and the amount of fuel that can be produced on Mars. Jupiter is the largest planet in the solar system, a gas giant with more than 2.5 times the mass of all the other planets combined, yet its mass is still less than 1,000th that of the Sun. Interestingly, Jupiter is the only planet in the solar system whose barycenter with the Sun lies outside the Sun's volume. A barycenter is the center of mass around which 2 or more objects orbit, determined by their gravitational interaction. It's the point where their masses are in balance. For instance, it's not entirely accurate to say that Earth revolves around the Sun. More precisely, both the Sun and Earth revolve around their common center of mass. However, because Earth is far less massive than the Sun, their barycenter lies inside the Sun. In contrast, the barycenter between the Sun and Jupiter is outside the Sun, though only by about 7% of the Sun's radius. Jupiter is the 3rd brightest natural object in the Earth's night sky, following the Moon and Venus. It has the fastest rotation of any planet in the solar system, completing 1 rotation in less than 10 hours. This rapid spin causes Jupiter to take on an oblate shape, making its equatorial diameter 9,276 kilometers longer than its polar diameter. One of Jupiter's most famous features is the Great Red Spot, a massive, persistent anticyclonic storm that has been raging for at least several hundred years and is roughly 3 times the diameter of Earth. Jupiter has 95 confirmed moons. Among this extensive family, 79 are less than 10 kilometers in diameter. The 4 largest moons are Io, Europa, Ganymede, and Callisto, with Ganymede being the largest moon in the solar system, measuring about 5,268 kilometers in diameter, larger than the planet Mercury. Scientists believe that Europa, Ganymede, and Callisto all harbor subsurface oceans, potentially creating conditions suitable for life. However, Europa is considered the most promising. It is thought to contain more water beneath its icy crust than all of Earth's oceans combined. This ocean may be in contact with the Moon's rocky mantle, providing opportunities for chemical interactions that could support life. NASA's Europa Clipper spacecraft, launched in October 2024, is set to perform nearly 50 flybys of Europa to investigate this intriguing moon in greater detail. Saturn is the second largest planet in the solar system, following Jupiter. As a gas giant, it has an average radius about 9 times that of Earth, yet its density is only 1/8 of Earth's, approximately 0.69 grams per cubic centimeter. This means that if there were a body of water large enough, Saturn could theoretically float in it. While all 4 giant planets in the solar system possess rings, Saturn's rings are undoubtedly the most captivating. Composed mainly of ice particles, along with smaller amounts of rocky debris and dust, these rings extend from 6,630 to 120,700 kilometers outward from Saturn's equator, averaging around 20 meters in thickness. Among Saturn's many satellites, Titan has garnered significant attention. It is the second largest moon in the solar system. Its atmosphere is primarily composed of nitrogen, with traces of methane, making it somewhat similar to Earth's. Scientists have speculated that beneath Titan's thick clouds, there might be alien life forms that rely on liquid methane. On July 1, 2004, the Cassini-Huygens probe entered Saturn's orbit to study the planet and its moons. On December 25, 2004, the Huygens lander separated from the Cassini spacecraft and touched down on Titan on January 14, 2005. However, the images sent back by Huygens were somewhat disappointing to scientists. With surface temperatures around -179 degrees Celsius and no internal heat sources detected so far, the presence of liquid water has been ruled out. While the possibility of life on Titan can't be entirely dismissed, fewer scientists remain optimistic about finding it. However, the disappointment didn't last long. Soon, Cassini made an unexpected and major discovery that sparked excitement. This discovery would become the greatest achievement of Cassini's journey to Saturn. Before Cassini's arrival, scientists were primarily focused on Saturn's rings, or Titan. Few paid attention to Enceladus, a moon just 1/10 the size of Titan. When the Voyager spacecraft flew past Saturn in the early 1980s, they didn't find anything unusual about this crater-covered little moon. But 30 years later, that view proved short-sighted. On February 17, 2005, after releasing the Huygens lander, Cassini flew within 1,264 kilometers of Enceladus and captured images. In these images, scientists were thrilled to see plumes erupting from Enceladus' surface, indicating volcanic activity. From that point on, Cassini's most important mission became repeated flybys of Enceladus, at one point even coming within just 25 kilometers of its surface. Based on data returned by Cassini, scientists discovered that icy water particles and gas erupt from the moon's surface at approximately 800 miles per hour. These eruptions appear continuous, generating a massive halo of fine ice dust around Enceladus, which supplies material to Saturn's E-ring. The gaseous envelope of the plume contains several gases, including water vapor, carbon dioxide, methane, and possibly small amounts of ammonia, carbon monoxide, or nitrogen gas, along with salts and silica. Surprisingly, the density of organic materials in the plume is about 20 times denser than scientists expected. They determined that the jets are fed by a global ocean beneath the moon's surface. Since Enceladus's ocean supplies the jets, and the jets produce Saturn's E-ring, studying material in the E-ring equates to studying Enceladus's ocean. The E-ring is primarily composed of ice droplets, but also contains peculiar nanograins of silica, which can only form where liquid water interacts with rock at temperatures above about 90 degrees Celsius. This, along with other evidence, suggests the presence of hydrothermal vents deep beneath Enceladus's icy shell, similar to those found on Earth's ocean floor. All of this has revolutionized scientists' thinking, making Enceladus a promising candidate in our search for worlds where life could exist.
Cassini is a mission of firsts. Time and time again, it has continued to surprise us. Astounding observations. It has changed our thinking irrevocably.
Uranus stands out among the planets in the solar system with an extreme axial tilt of nearly 98 degrees, making its rotation axis almost parallel to its orbital plane. It takes 84 Earth years for Uranus to complete one orbit, and since its axis points in the same direction throughout, each season lasts 21 years. This unique tilt means its polar regions experience continuous daylight or darkness for up to 42 years. Adding to Uranus's mystery is its irregular magnetic field, which is both tilted and offset from the planet's center. Interestingly, Neptune's magnetic field is also tilted about 47 degrees from its rotational axis and is similarly offset, though not as dramatically as Uranus. Another fascinating aspect of Neptune is its orbital interaction with Pluto. Pluto's orbit is tilted at a 17-degree angle compared to the plane of the 8 main planets. And while Pluto is often considered farther from the Sun, there was a period when it was actually closer to us than Neptune. Although Pluto is smaller than Earth's moon, it was considered the 9th planet in the solar system after its discovery in 1930. However, in 2006, the International Astronomical Union redefined what qualifies as a planet. According to the new definition, a planet must meet 3 criteria. It must orbit the Sun, it must be spherical in shape due to its own gravity, it must have cleared its orbit of other debris. Since Pluto shares its orbit with numerous small bodies in the Kuiper Belt, it doesn't meet the 3rd condition and was reclassified as a dwarf planet. Pluto has 5 satellites, the largest of which is called Charon. There has always been controversy over whether Charon should be classified as a satellite of Pluto. Charon is quite large, with a diameter about half that of Pluto, and its gravity is strong enough for it to be spherical. The common center of mass between Charon and Pluto lies outside of Pluto, which means they form a double dwarf planet system. However, the power of tradition is strong, and so far the International Astronomical Union still classifies Charon as a satellite of Pluto. You might think that as Pluto has been reclassified away from the ranks of major planets, interest in it would fade. However, that is not the case. In July 2015, Pluto welcomed its first visitor from Earth, the New Horizons spacecraft. Scientists were astonished by the images returned by New Horizons, revealing that Pluto is vastly different from previous expectations. It is a vibrant and geologically active world. Pluto has a distinctive heart, a signature feature captured by New Horizons, with its vast nitrogen glacier stretching over 1 million square miles. There is likely a vast liquid water ocean sloshing beneath Pluto's surface, suggesting it may still be tectonically active. Scientists have analyzed the data and concluded that Pluto was, and may still be, volcanically active. Numerous indications suggest that a type of cold, slushy cryolava has flowed across the surface at various points. Scientists refer to this process as cryovolcanism. Additionally, the New Horizons mission captured stunning images of Pluto's atmosphere backlit by the sun, revealing that its sky is actually blue, much like Earth's. If humans were to land on this planet one day, would astronauts feel at home?